If the Matrix were real, you probably would not see green code falling down a wall. You would not catch a black cat walking twice through the same doorway. You would not look at a spoon and watch it bend because the system forgot what metal is supposed to do. Those are human ideas of a glitch. A real simulation would have a different problem. Cost. How much does it take to render a universe? How much detail does a world need when no one is looking? And if reality was built to save processing power, where would the savings appear? This episode is about a reconstructed file known as Lattice 9. It did not claim to prove that the universe was artificial. It asked a quieter question. If the world was rendered, would physics already look like the perfect hiding place? Welcome to Terra Chrono. If you like archive stories where the simple explanation becomes the least interesting one, like the video, subscribe to the channel and turn on notifications. The first page of the Lattice 9 file contains no photograph, only a sentence typed across the center of the page. Do not search for errors. Search for economy. That was the shift. Most people imagine a simulated world as a machine that occasionally breaks. A tree repeats. A stranger says the same phrase twice. A reflection goes wrong. But a system advanced enough to create a convincing universe would probably not fail in such an obvious way. It would not be sloppy. It would be efficient. The Lattice 9 researchers began with a simple model. In a video game, the whole world is not fully drawn at all times. Distant mountains can be simplified. Rooms behind closed doors can be inactive. Textures sharpen when the camera moves closer. Characters outside the player's path can become probability, then detail. The player does not notice this because the world is built around attention. It becomes exact where exactness is required. The file asked whether a universe could do the same thing without ever revealing the trick, not by reducing a mountain into a low-resolution shape, not by turning stars into painted dots, but by making the rules of reality themselves depend on limits, thresholds, and measurement. This is where the story leaves science fiction and enters a stranger room. In 2003, philosopher Nick Bostrom published an argument that made the simulation question difficult to dismiss. The argument was not that we are definitely living inside a computer. It was a trilemma. Either civilizations like ours almost never survive long enough to create extremely advanced ancestor simulations, or they survive but almost never choose to run them. Or they do run them, and simulated observers eventually outnumber original observers by an enormous margin. If the third option is true, then a randomly chosen conscious observer might be far more likely to be inside a simulation than outside one. The unsettling part was not the technology, it was the math. One real civilization could run many simulated histories. Each simulated history could contain billions of people. If those people have experiences like ours, then the number of observers inside simulations could become much larger than the number of observers in base reality. Suddenly, the question was not, can a machine fake a world? The question was, if enough worlds can be faked, why assume this is the original one? Lattice 9 took that argument and moved it from probability to evidence. If simulated worlds can exist, what would their physical fingerprints look like? The first suspected fingerprint was resolution. Every digital image has a limit. Zoom far enough and the smooth curve becomes squares. Listen closely enough and a recorded sound becomes samples. Measure finely enough and a continuous illusion begins to reveal its grid. Physics has its own language of limits. There is a Planck length, an unimaginably tiny scale built from fundamental constants. There is a Planck time, a scale so short that our usual descriptions of time begin to lose meaning. There are quanta, packets of energy that made the old idea of smooth continuous exchange impossible to keep. It is tempting to say, there it is, the pixels of reality. But the file was careful. Planck length is not proof of a cosmic screen. Quantum theory is not a leaked graphics engine. The researchers wrote the warning 3 times. A limit is not automatically a pixel. Still, limits matter, because if a simulated universe had to manage cost, it would not need visible pixels. It would need rules that prevent infinite detail from being demanded. It would need a bottom floor. Somewhere below every measurement, every distance, every collision, the system would need to say, no more resolution is available here. The second suspected fingerprint was measurement. In everyday life, objects seem to have complete properties, whether or not anyone checks them. The coin is heads or tails under your hand. The book is on the shelf when you leave the room. The moon is there when the window is closed. But at quantum scale, reality does not behave like a finished photograph. Systems can be described as probabilities. Measurement changes what can be said. Interaction forces a definite outcome. This does not mean consciousness creates the world. The Lattice 9 notes underline that point. An observer in physics is not necessarily a human mind. It can be an instrument, a collision, an interaction with an environment. But even without the mystical version, the pattern is strange. The world appears to carry possibilities until something requires a result. For a simulation investigator, that is exactly where the question becomes dangerous. Not because quantum mechanics proves we are rendered, because it shows that reality is comfortable with delayed exactness. The file called this the closed-door principle. If nothing can extract the information, the world does not owe you a final image. The third suspected fingerprint was information density. Black holes made this unavoidable. For decades, physicists struggled with what happens to information when matter falls past an event horizon. The deeper the question went, the more reality began to sound less like solid stuff and more like accounting. Information could not simply vanish. Entropy had to be counted. The surface of a black hole seemed to matter in a way that made volume less fundamental than expected. This led to one of the strangest ideas in modern theoretical physics. Maybe a three-dimensional region can be described by information on a boundary. The holographic principle does not say we live in a computer game. It does not say your apartment is a projection from a wall, but it does suggest that the deep structure of reality may be written in information terms. Area, boundary, encoding, entropy. The Lattice 9 file treated this as the third warning light. If the universe is not made only of things, but also of the information required to describe things, then the simulation question changes shape. It stops being a question about fake objects. It becomes a question about storage. How much information is needed to make a room real? How much is needed to make a memory real? How much is needed to make a star real, if no measurement will ever reach it? The researchers designed what they called the render test. The test did not look for broken walls or repeated faces. It looked for places where reality seemed to avoid unnecessary commitment. A distant object not fully specified until observed. A particle not forced into a definite answer until interaction. An information limit that prevented infinite inspection. A horizon that stored less like a volume and more like a surface. None of these was proof. Each one had a normal scientific explanation. That was the frustrating part. The file did not contain one impossible fact. It contained a pattern of possible economies hiding inside legitimate physics. The investigators wrote that a bad simulation would reveal itself through errors. A good simulation would reveal itself through elegance, and a perfect simulation would not reveal itself at all. It would make its shortcuts indistinguishable from natural law. This is the hardest version of the matrix question. Not whether a computer could draw a table, not whether your memories could be fabricated, not whether a person could be fooled by an artificial sky. The harder question is whether reality would need to be artificial to behave this way. Maybe the universe is not simulated. Maybe information is fundamental because that is simply what reality is. Maybe measurement matters because the world is quantum, not because it is rendered. Maybe horizons count information because gravity and quantum theory meet in a way we still do not understand. Maybe the matrix is the wrong metaphor. Or maybe it is too primitive. Because if the world were rendered at the level of physics, it would not need cables in the back of your head. It would not need agents in sunglasses. It would not need a loading screen. It would only need rules. Rules that decide what can be known. Rules that limit how far a measurement can go. Rules that turn possibility into fact only when fact becomes necessary. The final page of the Lattice 9 file is almost empty. There is a photograph of a room, a chair, a clock, a table, a white wall, nothing strange. Under the photograph, someone wrote, "The room is complete because the picture asks for it." That sentence is the part that stays with you. If reality is real, the room exists before the photograph. If reality is rendered, the photograph may be the reason the room becomes specific. And if the simulation is perfect, there may be no experiment that can cleanly separate those two statements. That is why Lattice 9 never ended with proof. It ended with a warning. Do not expect the world to flicker. Do not expect the sky to tear open. Do not expect the code to show itself. If the matrix is real, the evidence may look exactly like physics. And the most disturbing possibility is not that something is wrong with the world. It is that the world may be working perfectly. If you want more archive files like this, like the video, subscribe to Terra Chrono and turn on notifications.